Hello, science class. So I'm going to talk about the experimental method. If you might remember in school in science class previously, you guys learned about the scientific method. So the scientific method is a really general process, but I'm going to talk about the experimental method, which is what a lot of people actually do call the scientific method. So it's confusing. I call it the experimental method. It's just really how science. If you ever wondered what a scientist does, they take a question they have about nature or maybe an engineering problem, and they use this method to help solve their problems. Now, this is only 6 steps. There's lots of steps in between, little sub bullet points that they use. But we're just going to talk about this in general. And over the next 3 days, you guys are going to look at some experiments and identify how those experiments work and kind of break them down. So let's get started. So the experimental method always starts with, number one, a question about nature or maybe, like I said, a problem. After you have your question, you should probably do some research to understand it a little bit better. Number three is then you write a prediction about your problem. And you guys might have also heard the word hypothesis. I like the word prediction a little bit better. I think it's a little more succinct. So you write a prediction about a problem, plus an if-then statement. We'll look at some examples in a second. The next step, number four, is to test your prediction, to actually carry out an experiment. Number five, then you gather some data. 6, reflect and write a conclusion. So let's look at a few examples. So number one, determine a problem. So the example we're given here is that when the Titanic sank, what happened to the water level on shore? So maybe that's something you want to know about. When boats sink, when boats sink, what happens to the water level around the boat or far away on the shore somewhere? So before we even do an experiment on this, maybe we should research this. What causes water level to go up or down in the first place? That would be good to know. After we've thought about the problem, done some research, then it's good to make a prediction. So before we actually do an experiment, we could make a prediction. So when the Titanic sank, the water level rose, it dropped, maybe it stayed the same. Number four, we actually do the experimenting. So how could we test our prediction? I guess there's lots of ways you could do it. I guess you could put a boat in the ocean and then just have actually somebody recreate the scenario. Now, that's pretty expensive. That'd be the most accurate way to do it, but it's kind of hard to sink a boat. That would cost a lot of money. It could be kind of dangerous. So maybe when we want to do a scale model, maybe we could just put a boat in a bathtub and see what happens to the water level. Maybe we could use a pool and sink a toy boat into a pool and see what happens to the water level. So number four is just about thinking about how we're going to set the experiment. And after we have the experiment set up, well, we want to know about the water level, right? So we should be measuring that water level. Is it going up? Is it going down? Is it staying the same? How are we going to do that? That's all in number four. Figuring out how we're going to do the experiment and actually doing the experiment. Number five is you're gathering data, analyzing the results. So, okay, you've done the experiment, you've sunk the boat, you've measured the water level somehow, and now you're gathering all your data. So, hopefully, and it's probably a good idea for scientists to do the experiment more than once. So, the first time, how much did the water level go up or down? Second time, how much did it go up or down? And so on. Gather all that data, get it all together. Number 6 is you reflect and draw conclusions. So maybe your prediction was, okay, if the boat sinks, then the water level is going to go down. But your data is showing you, oh no, it actually went up. So number 6, you're comparing your data to your prediction. And if there's something wrong with your prediction, well, maybe you should do another experiment. Maybe there's something wrong with your question. You're asking the wrong question, like maybe the water turns green or something. I'm just making it up for example. I know it sounds silly, but so number 6 is kind of, did you get a result that makes sense? Do we need to repeat the experiment? Do we need to rephrase the question and redesign the experiment? So those are the 6 steps of the experimental method. Let's talk about experimental variables. So experimental variables help us understand how an experiment works. And there's two main types of variables that I'm going to have you guys focus on: independent variable and dependent variable. If you're in my physical systems class, we might also look at the control and constant variables, but that won't be later on until next week. So the independent variable is something that's suggested by the experimenter. It's what you can actually control. Dependent variable is something that changes in response to that independent variable, or is what you measure. And that what you measure is what really helps me identify a dependent variable. And I'm just talking personally. So this week I'm going to have you guys look at a lot of examples of experiments and decide what is the independent variable, what is the dependent variable. It always helps me to start with the dependent variable. So let's go back to our Titanic example. So our prediction might have said something like, when the Titanic sunk, the water level went up. Okay, so that's our prediction. We haven't done the experiment yet, but that's our prediction. What is the independent variable and dependent variable? Well, dependent variable is what you're measuring. So what we measure is what we really want to know about is the water level. So we're measuring after the boat sinks, does the water level go up or does it go down? Independent variable is what you control. And I think that's really important to understand. The independent variable is something that you have control over. So if you are in this example, you are the ones that are sinking the boat, and you can't tell the water level how much to rise or how much to fall. Yes, the boat sinking has an influence on the water level, but you cannot actually control that water, how much it goes up or down. You can control how far the boat goes down to the water. So since the independent variable is what you control, how far the boat goes down would be your independent variable. Again, dependent variable is what you measure. That would be how far the water level goes up or down. I'm going to skip over these for now. Let's do one more example. Maybe this guy's, so we're not given a question here, but this guy is thinking about popcorn and how to make it pop better. So his prediction was, storing popcorn in the freezer makes it pop better. I mean, I know that sounds ridiculous. Who puts popcorn in the freezer? Well, just go try it yourself. No, I'm just kidding. But, so this is just a way to address these questions and figure out, well, what can make it pop better? So before I go to the next slide, I'm sure you guys could already peek at it if you want to, but let's just think about the independent variable and dependent variable. Storing popcorn in the freezer makes it pop better. So dependent variable, what am I trying to measure? What am I trying to really know about popcorn? Well, when I say pop better, I think this could be reworded a little bit. Do I want it to taste better? Do I mean more kernels are popping? Something like that would be my dependent variable, because that's what I want out of this experiment. So maybe my dependent variable is how many kernels pop. Don't you hate it when you pop a bag of popcorn and there's like half the seeds don't even pop? So, okay, so maybe my dependent variable is how many kernels have actually popped. In my independent variable, that's something that I can control. So I can control whether it's stored in the freezer or the pantry. So if I'm going to design an experiment, maybe I put one bag in the pantry, one bag in the freezer, and then see which one pops more kernels. So in that case, my independent variable would be the storage temperature. Is it going to be stored at room temperature or at below freezing? My dependent variable, again, is what I'm measuring, so the number of popped kernels. And here's the answers here. Independent variable is my storage temperature. Dependent variable, my number of my popped kernels. So to give you guys another hint, dependent variable is something that you cannot control. So in this experiment, I cannot put a little magic wand in the microwave and decide, you're going to pop, you're going to pop, you're going to pop. That's not how it works. The number of popped kernels is out of my control. Once I put that bag in the microwave and let the microwave go, I really couldn't tell you which kernels are going to pop and which aren't, because I don't know. It's just purely statistics at that point. But I can control the storage temperature. I can control whether it goes in the pantry or the freezer. That's my independent variable. So I'm going to stop there on the slideshow. Again, I didn't go over control or constant variables. Those are important. I'm just not going to go over them right now. So tomorrow you guys are really going to start working on identifying what an independent variable is, what a dependent variable is, as a part of an experiment that I'm going to give you guys. So look forward to that. And if you have any questions, this is my first time doing a video lecture on slides. If you have any questions, you can always go to YouTube where you find this video, leave a comment there, leave a comment in Google Classroom, email me, text me, call me, whatever. I have lots of lines of communication open, and in any way of those ways work with me. And I will see you in class.